Thank you for your purchase of the DPS629 differential pressure transmitter. This video is to help guide you through the process of inspection and installation of the sensor. The purpose of the DPS629 is to monitor the difference in pressure between the supply and return lines of your pumping system and provide a signal to your process controller that is used in achieving maximum energy efficiency. Since the process fittings of the transmitter are fixed in place, plan to connect the process water piping to the transmitter first. Select the location where the temperature of the unit will be between 0 and 175 degrees Fahrenheit and will not be subject to excessive shock or vibration. For optimal performance of the sensor, it should be used in an area where temperature will be maintained near 70 degrees Fahrenheit. The process connection on the DPS629 is 1/4 inch female NPT, so the mating end of the process piping must be a 1/4 inch male NPT. Use pipe thread, sealant tape, or other suitable pipe joint compound when making connection to the pressure source. Avoid excess sealant which could block the pressure passage. When monitoring liquid pressures, air trapped in lines can cause incorrect readings. Bleed fittings or similar mechanisms should be used to bleed off any trapped air. Warning: torque on the hex fittings may damage the sensor. When installing, put a wrench on the fitting to hold in place while tightening piping so that the sensor is not over-torqued in the housing. For your convenience, bleed fittings are already installed on the DPS629-3V models. To bleed off any system air, once you've completed piping into the manifold block, start with valve V1 open and valves V2 and V3 closed. Slowly open valves V2 and V3. Once the pressure has stabilized and is equal on the high and low side of the transmitter, valve V1 can be closed and normal operation can proceed. Gently twist the bleed fittings near the high and low pressure port of the transmitter counterclockwise to loosen the fitting until you see a small, steady flow of water escape the fitting, then retighten. Begin by selecting an appropriate length of flex or rigid conduit and map out the path from the transmitter to the control box. For reference, the conduit connection of the DPS629 is 1/2 inch. Next, open the housing by using a Phillips head screwdriver to remove the screws that anchor the plate in the center of the housing. An external power supply delivering 13 to 30 volts DC with minimum current capability of 40 milliamps DC per transmitter is required to power the control loop. The range of the appropriate receiver load resistance for the DC power supply voltage available is expressed by the following formula, where RL is equivalent to the receiver load resistance is equal to the voltage of the power supply minus 13 divided by 20 milliamps DC. Now you're ready to wire the unit. Connect the positive output of the power supply to terminal 1 on the transmitter. For 4 to 20 milliamp output models of the DPS629, connect terminal 2 of the transmitter to the appropriate terminal of the VFD. To complete the circuit, connect the appropriate terminal of the VFD back to the negative output of the power supply. For voltage output models of the DPS629, connect terminal 2 of the transmitter directly to the negative output of the power supply. Connect terminal 3 of the transmitter to the appropriate terminal of the VFD. Then jumper the appropriate terminal of the VFD to the negative output of the power supply. When finished wiring, replace the cover on the housing. Ensure that the gasket aligns in its original mounting location and secure the screws so that the unit will be watertight. Once you've finished wiring the unit, it is recommended that you confirm operation by energizing the circuit and taking a few readings from the transmitter. This may be done by using a multimeter or by viewing the readings on the graphic interface. If necessary, you may adjust the zero and span values of the transmitter. To calibrate the transmitter, you'll need 3 pieces of equipment. First, you'll need a calibrated pressure source capable of generating a stable pressure value for the maximum range of the unit under test. You'll need a gauge capable of validating the calibration pressure. You'll also need a voltmeter or milliamp meter to calibrate the output. The transmitter is calibrated using the following procedure. Depending upon if it is a 2-wire or 3-wire system, connect the voltmeter or milliamp meter and power supply, being careful to observe polarities. Leaving the pressure ports vented, press and hold the 0 switch for about 4 to 5 seconds. The 0 point should now be set and if the display is present, the display will read 0. Calibrating pressure should begin with setting the 0 first, then the span, since the 0 set point will affect the span value. Once the 0 is set, your output reading should be close to 4 milliamps or 0 volts. Now, connect the pressure source and apply the high range rated pressure. When the pressure is stabilized, press and hold the span switch for about 4 to 5 seconds. The display, if present, will now read the calibration pressure. Provided that calibration is satisfactory, the setup process should now be complete. Power may now be applied to the system, and once at steady state, you may wish to make a few readings to confirm operation. The DPS629 should not exhibit any field performance issues, and most issues are related to wiring the unit and should be exhibited during startup. If the readings appear to be inaccurate, you may wish to check the loop resistance and that the wiring polarity is correct. If any other issues are observed, it is recommended to contact the TACO technical support team.
TACO Hydronic Systems. Do your best work.